Okay, so here is my ISTEM biofuel lesson developed by Louis Rossi, target grade 8. We are teaching from a technology, engineering, and design platform integrating math, science, and cognitive science. For the technology piece will be the virtual design platform Minecraft as well as the 3D printer. For the engineering and design will be the physical models that they build as well as the virtual models. Math concepts integrated will be algebra, ratios, scales. Science concepts integrated will be the environmental impacts and the carbon footprint, and cognitive science will be the systems thinking, which is where each scenario has its own perspective, which results in a solution. So first we identify the problem, and this is a real-world problem. Cars and pollution. Emissions from an individual car are generally low relative to the smokestack image many people associate with air pollution. But in numerous cities across the country, the personal automobile is the single greatest polluter, as emissions from millions of vehicles on the road all add up. Driving a private car is probably a typical citizen's most polluting daily activity, and that was cited from EPA.gov. So we're going to jump in. Right after the students are posed with the problem, they're going to start researching. So students will use systems thinking to begin their research on vehicles by considering multiple perspectives and taking into account the various costs that are associated with both diesel and gasoline cars. So first they'll be looking at the car cost from the perspective of biodiesel and gasoline. So they'll be comparing the cost of cars for each. They'll do the same for the fuel economy, where they'll take the perspective of biodiesel and gasoline and compare which car is better miles per gallon. And then we'll talk about the carbon footprint from an algae biodiesel perspective, which was a previous lesson leading up to this, and then a gasoline perspective on carbon footprint. And they'll be looking at the production as well as the emission. And here's where we launch the context. Once they're done with their research, we'll give them a commuter's perspective. So here we have hitting the road. At this stage, students are called upon to peer into the future to a day where both algae biofuel and gasoline are readily available. They are given a glimpse into the life of an average American commuter looking to purchase a car in the year 2061. They are provided with vehicle choices, job descriptions, salaries, work locations, and home addresses. And the question is, which car is most affordable for a 7-year period? Later on, we'll pose more questions such as, at what amount of time does it make sense to have one car over another? So we start with giving them their perspective from the commuter. So here we have a gentleman named John Smith. His occupation is an aerospace engineer. His salary is $320,000 a year. He works 250 days per year, and the commute should be rounded to the nearest tens place. And then we provide an address so students can go and figure out how many miles per year. We also give them the gas prices, projected gas prices for year 2061 for both. We give them the ride options. So the sedan, this is a biofuel lineup. The sedan is $52,000 up front, 47 miles per gallon. The supercar is $64,000 to buy, 70 miles per gallon. And the crossover is $58,000 to buy, 40 miles per gallon. And we do the same for the gasoline cars, as you can see. So then they have to figure out what car is most sensible and which car makes the most sense, not only from a 7-year perspective, but then later on they'll be asked to make these calculations for 20 years or 15 years. So what car is most sensible? At this stage, students are called upon to reflect on knowledge and info gained to construct algebraic equations to determine which car makes the most sense for their particular commuter over a period of time. They must compare and defend their outcomes utilizing knowledge gained throughout their research. And here's where you see the breakdown. So they take the different perspectives from the years, the commute, fuel cost, fuel economy, and initial price, and they'll lock those into an equation which will tell them which car will cost however much money based on whatever the year. So the variable here will be the year. So if we're talking about 7 years, the sedan, 7 years times 25,000 miles per year at a rate of 50 miles per gallon times the price per gallon plus the initial cost. So the total cost here for 7 years is $67,995, whereas the supercar after 7 years is $75,425. So it'll be interesting to see after 20 years which one will make most sense. And at some point, we would like to talk to the students about moral decisions. So if it's about the same amount of money and one leaves a less of a carbon footprint, then the students would be asked to make a moral ethnic decision. And then here's where they'll graph their equations to actually find out at what point does one car make sense over another. And here you can see that they took their original formulas, they put it into slope-intercept form, which is y equals mx plus b. Cost is the slope, x is the variable amount of years, and the initial cost will be their y-intercept. And they would do the same for all of the cars to compare. So once they've done the math portion, they'll begin designing their context. So here the students will use Minecraft blocks to design and determine locations of key components of their commuter's world. Examples include, but are not limited to, gas stations, biodiesel or gas, home and work. They will determine an appropriate scale based on the number of blocks provided. So they'll be given constraints will be 25 blocks. So they'll have to figure out a scale that works within those constraints. And an example would be 1 block equals 3 miles. Here's a picture of what it could look like for students. They're using physical blocks to represent a scale and also to plan out their world in the game. And then they'll start with their virtual build. So here students utilize the sandbox game Minecraft to replicate with greater detail their physical designs in a virtual setting. They'll be required to build a full-scale model at this point, and that will correspond to the placement and decisions made during the physical build. They're encouraged to design a realistic setting with futuristic characteristics. Once they've done that, we would like to concretize this lesson, give them something concrete to take away, something to remember this problem by. So in an effort to remind students of the problem of vehicle emissions create for our atmosphere, each group will be allowed to print a scaled version of their engineered and designed fueling station. And then as an extension, we can ask them, if people took this much time and effort when purchasing a car, would there be less pollution and why? And then another really cool extension question would be, if algae biofuel requires CO2 to grow, would it be possible to attach a photobioreactor to an exhaust of an 18-wheeler or train? If not, defend your response. But if so, design a sketch in your notebook of what it may look like, and be ready to defend why it may be possible and what the environmental impacts could be. So underpinning research. So here is from Sasha Barab, Constructing Virtual Worlds, Tracing the Historical Development of Learner Practice. This was in 2001. And the focus is not only on the interactions among students or between students and teachers, but on student resource interactions, especially student technology interactions. This is where they say in a 1-week camp, students worked in activity groups with 3-dimensional modeling software to develop virtual worlds. And what they found is that the findings suggest that becoming knowledgeable and skillful with respect to a particular practice or concept is a multi-generational process involving in terms of contextual demands and available resources. The tracings further reveal the reciprocal nature of learning and doing, with building conceptual understanding occurring in relation to local conditions and practicing, and doing practices being a part of a student learning. So this talks about when students build based upon the things that they learn, that the retention will be longer and their understanding will be increased. Here's another article by Sasha Barab, Grounded Constructions and How Technology Can Help. And our research focused on technology as a tool for facilitating learner inquiry within rich environments that situate the content being learned. In these environments, knowledge is not the thing or a product delivered to the students. Rather, knowing is a situated activity or a process supported by the use of technological tools. In other words, the tools that we have been researching establish opportunities for rich interactions with the potential to support learners and building understanding. These understandings are not abstract concepts, but grounded constructions that are situated and built out of a learner experience. So this whole project was kind of built and constructed and designed and engineered out of their actual experience. So how do we get buy-in? So as the research for gamification and student engagement as well as design-based learning continues to mount, publishers such as Scholastic, Pearson, and McGraw-Hill are beginning to enter this arena. These companies are large contributors in the educational market, and it would be reasonable to assume that they have influence over the approaches to learning and teaching at all of the local, state, and federal levels. As more design-based learning activity books begin to sell, the involvement of these companies may lead to the adoptions of new curriculums and assessments to support their innovative products. An example is Scholastic has already entered the Minecraft world by publishing various student handbooks. They have sold over 6 million copies at $10 a piece. You do the math.